point out on this number 48 from 3-4, we're at a huge advantage because of this graphing calculator. Without the graphing calculator, first thing I'd probably do, possible rational zeros are these 8 points. Then maybe I test them all. Guess what, guys? Yeah, Matt? What's that? Okay, yeah, so if you use Descartes rule, you can knock it down to 4, right? But either way, I'm going to be testing zeros. But now look at the graph. Are there any real zeros? At least not in this range, and all these would fall in that range. So if there's any real zeros, they're irrational. So, whoa, what do I do? Well, let me show you. Thank goodness they gave me a hint. -1 plus 2i is a 0. So, what can I do with that? That's equivalent to something else. That's equivalent to saying blah blah is a factor. But what's blah blah? This is important that you know this. If I say 7 is a 0, then what do you have as a factor? X minus 7. If I say 4 is a 0, then you have x minus 4 is a factor. If I say -1 is a 0, well, I guess it's x minus -1, but we usually write x plus 1, right? So here I can say that x minus -1 plus 2i is a factor. So to find the rest of it, in other words, I want to divide this by that factor, we use the synthetic division routine. I'll put c in here, -1 plus 2i. I'll write down the coefficients, 2, 5, 13, 7, and 5. And here I go. 2. -1 plus 2i times 2 is -2 plus 4i. Now I have to add. When I add, you only have to add the real parts because these are real numbers. So I'm just going to get 3 plus 4i when I add. Does that make sense to people? Okay. And now I multiply, oh boy, -1 plus 2i times 3 plus 4i, -3 minus 4i plus 6i plus 8i squared. That's -3 plus 2i plus 8 times -1. That's -3 plus 2i minus 8. Okay, after a lot of work, I get -11 plus 2i. When I add them, I get 2 plus 2i. All right. I'm getting tired because it's getting late. But let me tell you, what's the remainder going to be here? 0. Oh, I should keep going. -1 plus 2i times 2 plus 2i. I get -2 minus 2i plus 4i plus 4i squared. And that ends up giving me -6 plus 2i. So this is a 1 plus 2i. And when I do -1 plus 2i times 1 plus 2i, I get -5, which is really kind of fascinating. But it really does work. Okay? Now, I guess at this point, you can write down f of x equals 2x to the 4th. No. Let's write down our factor. X minus -1 plus 2i times, well, the rest of this is really kind of crazy. We go from here, the 2, to what? X cubed, because we knock it down a degree, plus, and this is really strange, 3 plus 4i x squared, plus 2 plus 2i x, plus 1 plus 2i. That's weird. But I'm just doing what I always did when I had real numbers in Chapter 3. Now, fact that's really cool. if z equals a plus bi is a 0, then so is z bar. You guys know what I mean by z bar? The conjugate. What would be the conjugate of a plus bi? It would be a minus bi. And I'll tell you what I'm going to do here, guys. I'm about to do another synthetic division because I know what has to be a 0. Negative 1 and then what? Minus 2i, because it's a conjugate. And so you know what I'm going to write down here? I'm going to write down all these coefficients. 2, 3 plus 4i, 2 plus 2i, and 1 plus 2i. And I'm going to do the exact same thing, and I'm going to get a 0 here. And not only will I get a 0 there, I'll just tell you what the other coefficients are. The other coefficients are 2, 1, and 1. It works out really nice. So now I get f of x is x minus negative 1 minus 2 plus 2i times x minus negative 1 minus 2i. And then I get the rest of this, 2x squared plus x plus 1, from this 2 and this 1 and this 1. And unfortunately, this last piece doesn't factor. But do you know how I could find more zeros? Quadratic formula. Because it's quadratic. Which brings me to the end of class.